So our next speaker is Kaylee Clark, who is a third-year PhD student in chemistry. And she knew she wanted to study chemistry when she got halfway through a degree in biochemistry and realized she hated biology. It's not an uncommon story. So with that, her title is Mixing It Up, Biosensors from Inexpensive Materials.
By show of hands, how many of you know someone with diabetes? Looks like most of you are raising your hands, but if any of you aren't, now you do. Hi, I'm Kaylee. I have type 1 diabetes. I'm one of over 422 million people living on this planet with diabetes. It's the 7th leading cause of death in the world. Clearly, it's a big issue. And to manage this disease, you need to closely monitor your blood glucose levels. With this high of a demand, you're probably thinking, there must be a ton of cost-effective ways to monitor blood glucose. I'm here to tell you firsthand, as a diabetic with health insurance, that these sensors are nowhere near affordable, especially on a grad student salary. Why are these so expensive? So right now, most of these sensors are made with expensive precious metals like platinum, which really drives up the cost. To address this problem, my research is focused on making biosensors out of inexpensive materials. I take graphite and a cheap plastic, add in an enzyme called glucose oxidase, mix it together, and make sensors. I'm literally taking pencil lead and plexiglass and making glucose sensors. And this is costing about $10 cents a piece to make, compared to the prohibitive $2,000 a year I currently spend on my sensors. And the sensors I'm making can be reused over and over again for quick response continuous glucose measurements without loss of signal. As much as I'd love to think as a selfish diabetic that glucose is the only molecule we need to worry about sensing, there are actually hundreds of important molecules to measure in the body: cholesterol, glutamate, lactate, just to name a few. And the incredible thing about these sensors that I'm making is that just by switching out the enzyme I'm using, I can sense different biomolecules. So for example, if I want to sense lactate, I switch out the glucose oxidase for lactate oxidase. And there are over 200 oxidase enzymes that fit into the scheme of my sensors, meaning these sensors can be applied towards hundreds of different molecules. We're not only excited to demonstrate the use of these glucose sensors as an inexpensive, easily fabricated alternative to expensive precious metal sensors, but we also want to apply multiple of these different types of sensors to simultaneously monitor different molecules. If we're successful, our hope is to cut the cost of treatment in half for millions of diabetics, including myself.